Hey everyone, so in this video I want to talk about collisions, and it's only the first video about collisions because collisions are actually a pretty complex topic in Bullet, so let's start simple. And what we have here is a rotated toy, which is on purpose, and I just put this into a bullet solver, and when I press start it falls down. Alright, straightforward so far. Let's talk about the first kind of collision, and that is a ground plane. In the bullet solver, under collision, surprise, actually at the bottom here we can activate the ground collision. So for now let's activate ground plane, and as the name suggests, this just activates a ground plane node inside as if we would have created it ourselves. And if we press start, then it looks like this. Straightforward. So this part is easy. A small note here, as you can see here, I'm fusing my geometry. So before I move it up, you can see that I'm actually fusing together some geometry here. And you should do the same if you want to create the same effect. If you don't fuse, then don't be surprised that this happens. If I press start, then my geometry falls apart. We will talk about this in, I think, 2 videos from here, but this is a big topic by itself. Just don't be surprised. If you want to follow along, just use a fuse with a 002 in my case, and then the whole geometry is 1 and everything is fine. Let's now talk about a second way of creating collisions before we go to the really complicated stuff, and that is if you just wanted to create our own ground. So for example, we have a grid here, which just, creates a slope. This could be a landscape or whatever. Now the bullet solver actually allows you under collision, where we activate the ground plane, to use a height field for that. So if we have something like this, of course, just like we learned in POPs, we use a height field. And for this, then we need a height field project. So the height field goes into the first input, the geometry into the second. And by default, the height field is way too big because it's usually used for terrain or landscape generation. So let's first make it smaller. And then very important, lower the grid spacing, because the height field is basically a 2-dimensional volume. So the grid spacing defines the resolution. Okay, so you would think now that you put this into an input of the RBD bullet solver, but actually you don't, because if you choose the height field option, you have to put in here a path. An OP input path actually, to my knowledge, will not work. That's because this is a wrapper. So we should create something like a path for us. So let's call this with a null an out height field. And if you want, you can just drop that in here or choose the path directly. And then you can see it uses our height field. And if I press start, you can see it recognizes the height field. It is a bit slow, so it's not always the best approach, but at least it is possible. So let me run this a little bit so that we can look at it in a faster way. And as you can see, the height field is recognized. We will use this later on. There is not much more to say here other than, you're able to use a height field. And as you can see, our height field was a bit too small for our toy. Anyway. This just as a side note, height fields are understood by Bullet. Where it gets a bit more complicated is if we actually use normal geometry. So for now, let's use a normal ground plane again, and let's ignore our height field and just use this little box here as an input. And you would expect, just like in Vellum, that it's the last input that we can use for our static objects, but it's actually the one next to it. So be careful that you don't use the wrong connection and then wonder why nothing is happening. It's the second from the right. And when you mouse over, you can actually see that. So when you look now through the simulation, you can see that the geometry turns blue like you would expect. And when we press start, okay, everything seems to work at first. Now let's analyze this a little bit. First of all, you need to understand one very important rule. Bullet does not understand SDFs. There's no case where Bullet can use an SDF. Bullet is the only simulation type that does not understand SDFs. We, I think, quickly talked about this. If I would create a normal DOPNet, which RBD bullet solver is just a wrapper around, then what's used internally is basically a static object. And remember, under collisions, we had 2 options here, the RBD solver and the bullet data. And this is very confusing because basically the RBD solver is used for everything except RBDs. And that is because in the past, the RBD solver collision calculation was the base for every simulation. And then Bullet came around, so only for rigid objects it was used, and therefore it's the only simulation type nowadays that does not use the RBD solver. And that also means when you look into this here, you will not find any volume representation. So this is basically what's going on under the hood. And this is all you need to remember, even though it might look like an SDF, Bullet does not use SDFs. Let's say it again. Bullet never uses SDFs. I'm saying this so often because it's very easy to forget that, because it breaks with every rule in Houdini. So this is why it's so important for you to understand that. But besides that, there's more things you need to understand. And this is actually what we will cover in the next video. Because if you actually look at the simulation carefully, and you might have already noticed that, if I press start, you can see the collision is actually not correct. So here, there is a weird collision. Even though it might look like this, the toy is actually not colliding with the box. And yet, there is some kind of, collision happening. And that is because what we're seeing here is not what is actually used for the collision. A little bit like SDFs, but again, it's not SDFs. To show what's going on, you can use the visualization tab. And then there are basically two ways of showing the collisions. We will talk about the collision geometry later. This is for the box basically. You can activate the show collision shape, which in our case we already kind of see. But more importantly for us is the active geometry, which is here under geometry. We can also activate the show collision shape. And here you can see, oh, interesting. This is actually the object that is used for collision, which you can see when you just run this, that the result is much more accurate for that object. Now what's happening here is basically an optimization. Bullet cannot work with concave objects. So what this actually is a concave object. So it turns it into a convex object. Don't worry, this is exactly what we will talk about in the next video. I just want you for now to understand that this is what's happening when you put any kind of collision object into the bullet solver. And before we finish this video off, so that we can talk about this in more detail, one small note on this. When you check your collision shape, so what's actually happening with the collision objects here under visualization, I would recommend to only, check it from time to time to see what's going on. And once you understand what it's doing, turn it off again. Because as you can see when I press start, it's actually now much faster. Or actually, let me compare this again. For that, let's activate the draw time, so the FPS down here. If I delete the cache and press start, you can see we reach more than 24 frames per second actually for the simulation. Let's say 30 frames per second. But as soon as I turn on my collision shape visualization, we go down to only 15 frames per second roughly, so half. And then with more complex scenes, it actually gets slower. I can't fully explain to you why that is, but just keep that in mind. The collision shape visualization actually slows down your viewport at the very least. So try to avoid keeping it on all the time. Okay, and in the next video, we will actually talk about how we can make sure that our actual object is used and not this weird representation that doesn't really represent our object accurately. More of it in the next video. So thanks very much and see you later. Cheers.